Welcome to the 8th grade Math Homework Helper Series. Tonight's homework is MS7, Multi-Stepped Equations, Word Problems. We're going to start by solving question number 1. Mr. Grande spent a total of $440.88 at the mall. He had $17.62 left. How much money did he have when he arrived at the mall? We have to set up a let statement, and since we're looking for money, we can use M. Any letter would be fine though. And we're going to let M equal the amount of money that he had when he arrived. So putting those numbers and that variable in, we start off with the amount of money he had, which we don't know when he arrived. We subtract from that the amount we know he spent, $440.88, and that should give us the amount we know he left with, $17.62. Now we can treat this as any one or two step equation. We're going to remove the 440.88 from this side of the equation, and if we added it to remove it on this side, we're going to have to add it on this side. And if we go ahead and do the addition, we should get $458.50. Now we take the M, the equals, and the answer, bring that down. And now we know how much money he arrived with, but we still haven't answered the question because it's a word problem. We have to answer it in a sentence. So we have Mr. Grande had $458.50 when he arrived at the mall. Okay, let's take a look at the next question. Question number 5. It says the Tigers won 8 games more than they lost. There were no ties. If the Tigers played a total of 78 games, how many games did they lose? So the first thing we need to do is to figure out what variables we want to use and create a let statement for that. So if we let x equal the amount of games they lost, then we know that they won 8 more games than they lost. So then we have x plus 8 equals the games that were won. Set that up as an equation. We take our x, number of games lost, plus the x plus 8, number of games won, and we know together these two need to come up to an answer, a total of 78. So we can start by combining the x's, and so that gives us 2x plus the 8 equals 78. Now we have a variable here, and we also have a number without a variable, and so my first goal is going to be to get rid of that number without the variable. So I can subtract 8 from both sides, and if I do that, it's going to cancel out over here. And if I subtract 8 from that side, I want to subtract 8 from this side, which is going to give me 70. And I can take my 2x, my plus, or my 2x, my equals, and my 70, and I can bring those down. I now want to isolate x, so I need to get rid of the 2. I can do that by dividing by 2, and if I divide by 2 on this side of the equation, I need to divide by 2 over here. I then bring down my x. If I divide 70 by 2, I get 35, but again, I'm not done until I put it back into the same sentence that it started out as. So, the Tigers lost 35 games. Okay, our last question. On his trip to the post office, Don paid $4.30 to mail a package, and he bought 39-cent stamps. He paid $13.66 altogether. So how many 39-cent stamps did he buy? So we know he spent $4.30 mailing the package, and the total he spent was $13.66. So how many 39-cent stamps could he have purchased to bring the total up to $13.66? Well, we'll start by creating a let statement, and we'll say let S equal the number of stamps. I chose S because it's S for stamps, but again, any letter is perfectly acceptable in solving this. Then we need to set up the problem. So we have $4.30 plus 39 cents times S, the number of stamps, equals $13.66. And we can start by removing this number. So we subtract 430 on this side, which means we need to do the same thing over here. And if we do that, we get $9.36. So now the 0.39s equals 936, all going to come down. I now want to remove 0.39 from this side to isolate s. If I do that on one side, I need to do it on the other, which is going to give me s equals 24. And then I put that back into a sentence. Don bought 24 39-cent stamps. Please use the solutions to these problems to help you answer the additional questions that are on your homework. And remember, the key to being successful in math is not only working hard, but working smart.